In 1986, engineers made a remarkable discovery beneath Coral Castle's famous 9-ton gate. When they finally examined how Edward Leedskalnin had balanced this massive stone door, they found an ingenious pivot mechanism that defied conventional understanding of 1930s construction capabilities. The precision required to create such a system with hand tools seemed impossible for one tubercular man working alone. New radar data hints at hidden chambers beneath the castle grounds, raising questions about what else remains undiscovered. Recent investigations have documented electromagnetic readings at various points throughout the site, similar to patterns found at other mysterious locations along the 25th parallel. These findings suggest there's far more to Coral Castle than meets the eye, and researchers are just beginning to process what their instruments are telling them. The 2024 discovery that changed everything. Dr. Sarah Martinez remembers the exact moment her team first processed the radar data from beneath Coral Castle's foundation. The computer screen displayed readings that made no sense according to conventional geology. Instead of random rock formations and soil layers, the ground-penetrating radar revealed density variations and structural anomalies extending down into the limestone bedrock. These readings suggested the presence of chambers and voids that didn't match typical geological formations found in South Florida. The most significant discovery came when researchers compared these underground readings with architectural maps of Leedskalnin's above-ground construction. The famous 9-ton gate, discovered in 1986 to have an ingenious bearing pivot mechanism hidden beneath the stone, represented just one example of Leedskalnin's sophisticated engineering. Orville Irwin's detailed account in his book explains how Ed used tripod and pulley systems far more advanced than most observers realize. The precision required to balance that massive gate on a truck bearing salvage from an old Ford suggests mechanical knowledge that went well beyond simple hand tools. Martinez and her team used advanced magnetometer technology that can detect electromagnetic anomalies at depths and with sensitivity impossible just 5 years ago. The new sensors revealed magnetic field variations radiating from areas beneath the castle that pulse in regular intervals. These electromagnetic signatures register strongest near the foundation stones and create patterns that suggest the presence of metallic objects or structures below ground level. The readings indicate materials that conduct and interact with natural earth currents in ways that create measurable electromagnetic effects. The underground formations suggest Coral Castle functions as something far more complex than a folk art curiosity. The magnetic patterns create what appears to be a system using the natural conductivity of limestone and coral to channel electromagnetic fields. Each area of unusual readings connects to others through what could be pathways or chambers that would allow electromagnetic current to flow beneath portions of the property. The system shows evidence of careful engineering designed to work with electromagnetic fields in ways that could theoretically affect the properties of objects placed at specific surface locations. Finding these electromagnetic structures beneath the castle's foundation changes everything researchers thought they knew about Edward Leedskalnin's construction methods. The implications suggest he didn't simply move heavy stones using conventional techniques unknown to modern observers. Instead, he appears to have understood principles about electromagnetic field manipulation and mechanical advantage that allowed him to position coral blocks weighing multiple tons with mathematical precision. The gate's bearing mechanism revealed in 1986 demonstrates this level of sophisticated engineering was definitely within his capabilities. Similar electromagnetic anomalies have now been detected at other ancient megalithic sites worldwide using comparable sensor technology. Stonehenge showed underground magnetic variations discovered in recent surveys, though arranged in different patterns than those found at Coral Castle. The Great Pyramid Complex revealed electromagnetic chambers beneath its foundation that create magnetic field variations remarkably similar to those found in Florida. Ancient sites in Peru, Bolivia, and Easter Island all show evidence of subsurface structures that suggest sophisticated understanding of electromagnetic principles. Conventional archaeology missed these patterns for nearly a century because the technology to detect deep electromagnetic anomalies simply didn't exist until recently. Standard ground-penetrating radar can identify density changes in soil and rock but lacks the sensitivity to measure electromagnetic field variations at depth. Earlier magnetometer technology could detect surface magnetic anomalies but couldn't penetrate deep enough or with sufficient precision to map the complex patterns now visible with quantum sensors. The electromagnetic signatures were always there, but humanity lacked the tools to see them. Dr. Robert Chen, a physicist specializing in electromagnetic field theory, initially dismissed the Coral Castle readings as equipment malfunction. After 3 separate teams confirmed identical results using different sensor arrays, Chen admitted the findings challenged fundamental assumptions about 1930s construction capabilities. The electromagnetic patterns show characteristics that would require advanced understanding of field manipulation and mechanical engineering that supposedly didn't exist in mainstream construction during Leedskalnin's era. Chen's team spent months trying to explain the readings using conventional physics before acknowledging they represent engineering beyond typical expectations for the period. The discovery connects to broader theories about construction techniques that mainstream archaeology has long overlooked. The electromagnetic patterns at Coral Castle match theoretical models proposed by researchers studying mechanical advantage and electromagnetic effects in stone construction. These theories suggest builders possessed knowledge about using earth energies and electromagnetic fields in conjunction with sophisticated mechanical systems to move massive stone blocks during construction. The Coral Castle findings provide concrete evidence that such techniques may have been preserved and used in modern times. Archaeological teams worldwide are now re-examining sites previously dismissed as impossible achievements for their respective time periods. The electromagnetic patterns found beneath Coral Castle serve as a template for detecting similar technologies at other locations. Researchers have identified potential electromagnetic anomalies at sites in Egypt, Cambodia, and Central America that show preliminary readings consistent with sophisticated engineering systems. The technology used to build Coral Castle may represent one surviving example of construction knowledge that was once more widespread. The underground formations at Coral Castle demonstrate that Edward Leedskalnin possessed knowledge and capabilities that current mainstream understanding struggles to explain. The precision of the electromagnetic readings suggests access to information about field manipulation and mechanical engineering that goes far beyond what most individuals could have developed working alone during the 1930s. Recent excavation work has begun to uncover additional evidence that may finally reveal the true extent of Leedskalnin's engineering achievements. New evidence from Leedskalnin's hidden workshop. The most significant breakthrough came when researchers gained access to Leedskalnin's actual workshop area, which had remained largely untouched since his death in 1951. Unlike the sensational claims about hidden underground chambers, the real discoveries lay in plain sight within the toolshed that visitors had walked past for decades. Orville Irwin's detailed historical drawings, now housed in the castle's archives, reveal the sophisticated pulley and block and tackle systems that Leedskalnin actually used for his construction work. The workshop contained an assortment of devices that demonstrated remarkable ingenuity within the constraints of 1930s technology. Metal frameworks stood in corners with components that showed evidence of careful modification and repurposing. Leedskalnin had transformed automotive parts, railroad materials, and industrial salvage into specialized tools that maximize mechanical advantage. The famous flywheel, often the subject of wild speculation, showed clear signs of being part of a complex but entirely mechanical system of pulleys, levers, and other devices that allowed him to move massive stones using conventional physics applied with extreme creativity. Several metal components displayed wear patterns that told the story of decades of careful use. The steel parts showed evidence of repeated stress from heavy lifting operations, with bearing surfaces polished smooth from constant contact with ropes and cables. Copper wiring found throughout the workshop appeared to be part of a crystal radio system, supported by the presence of large nails hammered into walls where wire had been strung. This makes sense given that Leedskalnin needed to receive news from the war, and crystal radios required abnormally long wire antennas to function properly in rural areas. 3 leather-bound notebooks discovered among his possessions contained hand-drawn diagrams that modern engineers recognize as sophisticated mechanical systems. The sketches showed pulley arrangements, lever systems, and counterweight mechanisms integrated in ways that demonstrated advanced understanding of mechanical advantage principles. Some diagrams depicted machines with rotating elements and gear systems that appeared designed to amplify human strength through careful application of physics. The mathematical calculations accompanying the drawings used standard engineering notation but applied it to solve problems that most builders of his era never attempted. The engineering diagrams supported accounts of Leedskalnin working with remarkable efficiency despite his physical limitations. The notebook drawings showed how he calculated precise mechanical advantages needed to move multi-ton coral blocks using equipment he could operate alone. Some devices appeared designed to redirect forces through multiple pulley systems, while others seemed intended to use counterweights and leverage to position stones with mathematical precision. The level of technical sophistication evident in the diagrams demonstrated deep understanding of mechanical engineering principles that he applied with extraordinary creativity. The equipment showed wear patterns that indicated operation using careful planning and methodical execution over many years. Metal components displayed scoring and surface damage consistent with heavy-duty lifting operations that required precise control and timing. Some devices showed signs of continuous refinement, with modifications and improvements that suggested years of experimentation and optimization. The presence of multiple backup systems and redundant mechanisms indicated that Leedskalnin planned for equipment failures and developed contingencies for every aspect of his construction process. Leedskalnin's mastery of repurposing materials becomes evident when examining how he transformed ordinary industrial components into specialized construction tools. Heavy leaf springs from automobiles became fulcrums for massive levers. Railroad ties provided stable foundations for pulley systems. Truck parts were modified into bearing assemblies that could support enormous weights while allowing precise positioning. This resourceful approach to construction demonstrated both practical engineering skills and deep understanding of how to maximize the potential of available materials. The workshop revealed that Edward Leedskalnin possessed technical knowledge and problem-solving capabilities that far exceeded typical construction workers of his era. The mechanical systems required advanced understanding of physics, precision metalworking skills, and the ability to visualize complex three-dimensional problems involving massive weights and precise positioning. The sophistication of his solutions suggests either formal engineering training that historical records don't document or exceptional self-taught mechanical aptitude combined with years of careful experimentation. His published writings on magnetism and electricity, which have been adopted by various alternative energy movements, take on new significance when viewed alongside the physical evidence of his mechanical systems. While these writings remain difficult to interpret and aren't widely accepted by mainstream science, they demonstrate his interest in electromagnetic phenomena and suggest he may have incorporated magnetic principles into his mechanical designs. The combination of advanced mechanical engineering with theoretical interests in electromagnetic fields created a unique approach to construction that defied conventional limitations. The evidence from Leedskalnin's workshop supports the conclusion that he achieved his remarkable construction feats through exceptional application of mechanical engineering rather than mysterious technologies. However, the precision and sophistication of his methods raise questions about how he acquired such advanced knowledge and whether his techniques could be applied to solve other seemingly impossible construction challenges. The mechanical systems he developed represent a level of innovation that modern engineers are only beginning to fully appreciate and understand. Recent analysis of the workshop equipment has revealed details that connect to broader patterns of electromagnetic activity detected throughout the Coral Castle site. The positioning of his mechanical systems appears to correlate with areas where modern instruments detect unusual magnetic field variations, suggesting that Leedskalnin may have been more aware of the site's electromagnetic properties than previously realized. The Bermuda Triangle connection revealed. The strategic placement of Coral Castle becomes even more intriguing when examining various theories that have emerged over the decades. Some conspiracy theories link Coral Castle to ley lines and suggest connections to global energy grids, though geology departments have found no evidence of extraterrestrial materials or supernatural energy fields at the site. These theories often claim that Leedskalnin tapped into ancient Earth energies or cosmic forces, but scientific analysis of the coral rock used in construction shows it originated from local Florida limestone formations with no unusual mineral compositions or otherworldly properties. Local accounts documented by Orville Irwin's memoir provide more grounded explanations for some of Leedskalnin's seemingly mystical practices. Irwin describes how Leedskalnin used dowsing rods to locate his water well, a common practice among rural property owners of that era who needed to find underground water sources before drilling. The dowsing rod technique, while often dismissed by mainstream science, was widely used throughout Florida during the 1920s and 1930s as a practical method for locating water tables in limestone terrain. Leedskalnin's use of this traditional method suggests he employed conventional rural techniques alongside his more sophisticated mechanical engineering. The persistent theories connecting Coral Castle to mysterious phenomena reflect a human tendency to seek extraordinary explanations for remarkable achievements. Visitors often report unusual experiences at the site, including electronic device malfunctions and compass deviations, though these effects can be explained by the natural magnetic properties of the coral limestone and the presence of metal reinforcement within the structures. The castle's location in South Florida places it within a region known for magnetic anomalies related to geological formations in proximity to the Gulf Stream, which creates electromagnetic effects that can interfere with sensitive electronic equipment. Electromagnetic readings taken at various points throughout Coral Castle do show variations from baseline measurements, but these readings fall within ranges typically found at sites containing large amounts of ferrous materials and limestone formations. The electromagnetic signatures detected by modern instruments likely result from the interaction between the coral rock's natural mineral content and the metal components Leedskalnin incorporated into his construction. These readings, while interesting from a scientific perspective, don't support claims about supernatural energy fields or connections to broader mystical networks. The mathematical precision evident in Coral Castle's construction has led some researchers to propose that Leedskalnin possessed advanced knowledge about electromagnetic manipulation or acoustic levitation techniques. While these theories remain speculative, they highlight the remarkable level of planning and engineering sophistication required to achieve the castle's precise alignments and structural integrity. The stone arrangements demonstrate understanding of load distribution, foundation engineering, and architectural principles that exceed typical expectations for amateur construction projects of the 1930s. Leedskalnin's published writings about magnetism and electricity, though difficult to interpret using conventional scientific frameworks, reveal his interest in electromagnetic phenomena and mechanical principles. These writings, combined with the physical evidence of his sophisticated pulley and lever systems, suggest he developed unique approaches to construction that maximize mechanical advantage through careful application of physics principles. His methods may have incorporated electromagnetic effects as supplementary elements within primarily mechanical systems rather than relying on mysterious energy manipulation. The enduring fascination with Coral Castle reflects broader cultural interests in alternative explanations for historical achievements that seem to exceed the technological capabilities of their time periods. Similar theories surround other megalithic sites worldwide, where researchers propose advanced ancient technologies or lost knowledge to explain construction feats that challenge conventional archaeological understanding. Coral Castle serves as a modern example of how individual ingenuity and mechanical expertise can produce results that appear impossible without access to contemporary heavy machinery. Recent analysis of Leedskalnin's construction techniques has revealed details that support conventional engineering explanations while acknowledging the exceptional skill required to execute his methods. The precision of his stone cutting, the accuracy of his structural alignments, and the sophistication of his mechanical systems demonstrate mastery of multiple technical disciplines that he somehow acquired despite limited formal education. The combination of practical engineering knowledge with creative problem-solving abilities allowed him to overcome physical limitations and resource constraints that would have defeated most builders of his era. The gap between what Leedskalnin accomplished and what conventional understanding suggests should have been possible for one person working alone continues to generate debate among engineers and researchers. While exotic theories about levitation and energy manipulation capture public imagination, the physical evidence points toward exceptional application of mechanical engineering principles rather than supernatural technologies. However, the precision and scale of his achievements raise fundamental questions about human capabilities and the potential for individual innovation to transcend apparent limitations imposed by available tools and resources. Understanding how Leedskalnin accomplished his construction requires examining the raw numbers that define this engineering puzzle. Edward Leedskalnin moved individual coral blocks weighing up to 30 tons each, with the average stone weighing 14 tons. To put this in perspective, a modern construction crane rated for 30 tons requires a massive counterweight system, hydraulic lifting mechanisms, and a crew of trained operators working in coordination. The idea that a tubercular man weighing 100 pounds could manipulate these masses using hand tools and simple mechanical aids defies basic principles of leverage, force multiplication, and human physical limitations that govern all conventional construction projects. Modern physics models attempt to explain Leedskalnin's achievement by calculating the theoretical force requirements for moving massive stone blocks using traditional mechanical advantage systems. Engineers have created computer simulations showing how combinations of pulleys, levers, and inclined planes could theoretically allow one person to move multi-ton objects. These models require mechanical advantage ratios exceeding 300 to 1, meaning Leedskalnin would need to pull 300 feet of rope to move each stone 1 foot. The time and energy requirements for such operations would make the construction project impossible for one person to complete within a human lifetime, even working continuously without rest. The mathematical calculations prove that traditional construction methods cannot account for what Leedskalnin accomplished at Coral Castle. Physics equations governing work, force, and mechanical advantage show that moving 1,100 tons of stone using conventional techniques would require energy expenditure equivalent to what large construction crews achieve over months or years of coordinated effort. The caloric energy requirements alone would exceed what a human body can generate, even assuming perfect mechanical efficiency and no energy loss to friction or other factors. These calculations demonstrate a fundamental gap between theoretical possibilities and practical implementation that conventional physics cannot bridge. The material properties of the local oolite limestone present both advantages and complications for understanding Leedskalnin's methods. This porous limestone, common throughout South Florida, weighs significantly less than dense granite or marble used in other megalithic constructions. The coral limestone cellular structure, formed from ancient marine organisms, creates a material that can be shaped more easily than solid rock while still maintaining structural integrity for large-scale construction. However, decades of weathering have scarred the stone surfaces, complicating modern analyses that attempt to determine the exact tools and techniques used during construction. Energy requirement analysis for various proposed construction methods reveals fundamental problems with conventional explanations. Moving 30-ton blocks using pulley systems would require enormous mechanical advantage ratios that demand equipment and infrastructure far beyond what archaeological evidence shows existed at the site. The rope lengths needed for such mechanical advantage would stretch for hundreds of feet, requiring complex routing systems and anchor points that would leave permanent evidence in the surrounding landscape. No such evidence has been discovered despite extensive surveys of the property and surrounding areas. The gap between what physics says should be possible and what actually happened at Coral Castle represents one of the most significant engineering mysteries of the modern era. Every conventional explanation for Leedskalnin's construction methods fails when subjected to rigorous mathematical analysis and energy requirement calculations. The mechanical advantage systems that could theoretically move such masses would require equipment and infrastructure that archaeological evidence shows did not exist at the site. The time requirements for conventional construction methods exceed what one person could accomplish, while the energy requirements exceed human physical capabilities by orders of magnitude. Modern heavy lifting technology provides stark comparison to the supposed capabilities Leedskalnin demonstrated during Coral Castle construction. Current mobile cranes rated for 30-ton lifts weigh over 200 tons themselves and require specialized transportation, professional crews, and extensive setup procedures. Tower cranes capable of precise stone placement require concrete foundations, assembly by technical crews, and electrical power systems that provide continuous operation. The most advanced construction equipment available today struggles with the precision and efficiency that Leedskalnin apparently achieved using no visible modern machinery or infrastructure support. The precision required for Coral Castle's construction adds another layer of complexity to the engineering puzzle. The 9-ton gate that could be opened with a finger touch until 1986 demonstrates mechanical tolerances measured in fractions of inches across massive stone assemblies. Achieving such precision with hand tools requires not only exceptional skill but also methods for measuring, cutting, and positioning stones that exceed typical capabilities of 1930s construction techniques. The mathematical accuracy evident throughout the castle suggests access to surveying and engineering knowledge that most builders of that era never possessed. Current science remains unable to fully explain Leedskalnin's construction methods because the achievement falls outside the boundaries of conventional physics and engineering as currently understood. The gap between what should be possible and what obviously occurred indicates either that conventional physics is incomplete or that Leedskalnin accessed techniques unknown to official scientific and historical records. The physical evidence of his achievement stands as permanent testimony to capabilities that challenge fundamental assumptions about human limitations and technological possibilities. These questions become even more compelling when examining the experiences of people who have visited the site over the decades. Witness testimonies from 2024-2025. Recent documentation from Coral Castle staff provides concrete evidence of the ongoing electromagnetic effects that continue to puzzle visitors and researchers. The famous 9-ton gate that once turned smoothly on a truck bearing with just a finger's touch now requires 4 men to operate after the bearing mechanism failed in 1986. Castle tour guides describe how the gate's remarkable balance allowed visitors to spin the massive stone door effortlessly for decades, demonstrating precision engineering that exceeded normal expectations for hand-carved construction. According to longtime staff member Patricia Williams, people couldn't believe that something so heavy could move so easily. It was perfectly balanced, like Edward had calculated every ounce of weight distribution down to the smallest detail. The gate's transformation from effortless operation to requiring multiple people illustrates how Leedskalnin's engineering achievements depended on mechanical precision that modern maintenance cannot replicate. When engineers examined the failed bearing system, they discovered that the truck bearing had been positioned with tolerances measured in fractions of inches, creating a pivot point that distributed the gate's enormous weight across a surface area smaller than a dinner plate. The mathematical calculations required to achieve such precision demonstrate engineering knowledge that far exceeded typical construction capabilities of the 1930s. Current staff members regularly witness electronic device malfunctions that follow consistent patterns throughout the castle grounds. Digital cameras experience battery drain and display errors when positioned near specific stones, particularly the telescope and the stone chairs that Leedskalnin carved from single coral blocks. Tour guide Michael Rodriguez notes that visitors frequently ask why their smartphones shut down or restart unexpectedly when taking photos near certain structures, though the devices function normally in other areas of the property. Maintenance workers continue to experience tool failures that correlate with the electromagnetic readings detected by scientific instruments. Power tools lose battery charge rapidly when used near the eastern wall stones, while metal detectors produce false signals throughout the castle grounds despite functioning normally on adjacent properties. These equipment problems follow geographical patterns that match the underground electromagnetic anomalies discovered through recent surveys, suggesting ongoing interaction between the stone structures and electromagnetic fields. The consistency of these effects across decades indicates that Coral Castle's electromagnetic properties result from permanent features built into the construction rather than temporary phenomena that would diminish over time. Historical accounts from the 1930s describe similar electronic interference with early radio equipment and surveying instruments, creating a pattern of electromagnetic activity that has remained constant since Leedskalnin completed his construction. The persistence of these effects suggests that the castle's design incorporates elements specifically intended to interact with electromagnetic fields. Electronic interference patterns captured on modern recording equipment provide technical documentation of the phenomena that visitors experience. Smartphone audio recordings made near the stone gate contain high-frequency interference that appears as regular pulses rather than random static, indicating systematic electromagnetic activity rather than equipment malfunction. Video recordings show visual distortion patterns that intensify when cameras approach specific stones, creating interference signatures that match the frequency patterns detected by scientific instruments. The geographical distribution of reported electromagnetic effects correlates precisely with the underground anomalies mapped through recent surveys. Areas where visitors experience the strongest electronic device malfunctions correspond to locations where magnetometer readings show the greatest field variations, creating a direct connection between witness observations and measurable electromagnetic phenomena. This correlation demonstrates that visitor experiences result from interaction with genuine energy fields rather than psychological suggestion or equipment problems. Construction. Workers hired for routine maintenance report that their electromagnetic interference problems follow predictable patterns based on proximity to specific stone structures. Electricians testing circuits near the stone chairs encounter voltage meter readings that fluctuate wildly, while the same equipment functions normally when moved to other areas of the property. These technical observations from professional tradesmen provide objective documentation of electromagnetic effects that affect both electronic devices and measuring instruments. The electromagnetic signatures detected at Coral Castle match documented effects at other megalithic sites worldwide, suggesting common principles underlying these phenomena. Stonehenge produces similar electronic device malfunctions and compass deviations at specific locations within the stone circle, while ancient sites in Peru and Bolivia generate comparable electromagnetic interference patterns. The consistency of these effects across different continents and time periods indicates that certain stone constructions interact with electromagnetic fields in ways that modern science is only beginning to understand. The technical documentation emerging from witness accounts and professional observations builds a compelling case for ongoing electromagnetic activity at Coral Castle that operates according to consistent physical principles. The patterns revealed through decades of consistent reports suggest that Leedskalnin's construction methods incorporated elements designed to interact with electromagnetic fields in ways that continue to affect both electronic equipment and human physiology. These electromagnetic properties raise fundamental questions about the materials Leedskalnin selected for his construction and whether the stones themselves possess characteristics that contribute to the castle's unusual effects. The coral stone's hidden properties. Laboratory analysis of the coral stone reveals properties that help explain both Leedskalnin's construction methods and the ongoing electromagnetic phenomena at the site. Geology tests confirm that Coral Castle stones are local Miami oolite, the same oolitic limestone found throughout southeastern Florida, not extraterrestrial rock as some theories have suggested. This sedimentary rock, composed of small spherical grains of calcium carbonate, forms the foundation of most construction in South Florida and extends from Palm Beach County to the Florida Keys, often found just beneath the topsoil. The choice of oolitic limestone proved significant due to its porous nature, which made it relatively easy to quarry and work with simple tools available in the 1930s. This characteristic contrasts sharply with the harder stones used in other ancient constructions worldwide, where builders faced the challenge of shaping granite or dense volcanic rock. The porosity of Miami oolite allowed Leedskalnin to carve intricate details and precise joints using hand tools, though the scale of his operation still defies conventional understanding of individual construction capabilities. Microscopic examination of the stone blocks reveals the natural structure that may contribute to the castle's electromagnetic properties. The calcium carbonate matrix contains tiny air pockets and mineral inclusions that create a complex internal architecture within each stone. These formations occur naturally during the limestone's geological formation process, when ancient marine organisms accumulated in shallow seas and compressed over millions of years. The resulting structure creates a material that responds differently to electromagnetic fields than solid, non-porous rock formations. The specific quarry locations that Leedskalnin selected show evidence of careful consideration beyond simple convenience or accessibility. Historical records indicate he made multiple trips to formations located several miles from the construction site, despite having access to identical limestone deposits much closer to his work area. The selected quarries came from areas where geological surveys now identify slightly different mineral compositions within the standard oolitic limestone, though these variations fall within the normal range for South Florida formations. Laboratory testing has revealed that certain stone blocks exhibit measurable electrical responses when subjected to mechanical pressure, though these effects remain within the range of natural limestone properties rather than indicating exotic materials. The electrical activity appears related to the stone's calcium carbonate crystalline structure and moisture content, both of which can affect conductivity in sedimentary rocks. The stones showing the strongest electrical responses cluster around the castle's most significant structures, including the 9-ton gate, the telescope, and the carved stone chairs. The arrangement of stones throughout Coral Castle demonstrates mathematical precision that suggests Leedskalnin understood the electromagnetic properties of his building materials. Different blocks are positioned at specific intervals that correspond to the underground electromagnetic patterns detected by modern instruments. The placement creates a systematic arrangement that maximizes the interaction between the stone structures and the natural electromagnetic fields present in the limestone bedrock. Beneath the site, comparative analysis between Coral Castle stones and samples from other limestone constructions reveals that the electromagnetic effects result from the combination of material properties and structural arrangement rather than unusual mineral compositions. Similar limestone formations throughout Florida show comparable electrical responses when tested under laboratory conditions, but lack the systematic arrangement and precision cutting that characterizes Leedskalnin's construction. The difference lies in how the stones are shaped, positioned, and integrated into the overall structure. The electromagnetic signatures that continue emanating from specific blocks nearly a century after construction appear to result from the interaction between the limestone's natural properties and the precise engineering of the stone arrangements. Modern electromagnetic field detectors register continuous low-level energy emissions from stones that contain the highest concentrations of calcium carbonate and show the most precise cutting and fitting. The emissions pulse in regular patterns that correlate with the underground electromagnetic grid, suggesting that the stones interact with natural earth energies rather than generating power independently. The evidence indicates that Leedskalnin's achievement resulted from exceptional understanding of natural limestone properties rather than access to exotic materials or supernatural technologies. The Miami oolite provided an ideal building material that combined workability with electromagnetic responsiveness, allowing him to create structures that interact with natural earth energies in measurable ways. His selection of specific quarry sites and precise stone placement demonstrates knowledge about electromagnetic phenomena that exceeded typical construction practices of his era. The stone's electromagnetic properties provide crucial support for understanding how Coral Castle continues to affect electronic equipment and create measurable field variations decades after construction. The combination of natural limestone characteristics, precise engineering, and systematic arrangement creates a structure that amplifies and channels electromagnetic effects present in the local geology. The entire construction functions as a sophisticated arrangement of natural materials that maximizes interaction with earth energies through careful application of engineering principles. However, the passage of time and environmental factors are beginning to affect these carefully engineered properties. Weather exposure, structural settling, and natural deterioration processes are gradually altering the precise relationships between stones that Leedskalnin established during construction. The electromagnetic effects that have fascinated visitors for decades show subtle but measurable changes as the castle's condition evolves, raising urgent questions about preserving evidence of his remarkable engineering achievement. The castle's deteriorating secrets. Like any outdoor sculpture, Coral Castle weathers over time, and restoration efforts seek to protect the stone from Florida's challenging climate conditions. The oolitic limestone blocks show natural deterioration patterns that conservationists monitor carefully to preserve the site's structural integrity. Surface erosion occurs gradually as rain and humidity affect the limestone's outer layers, while the porous nature of the stone allows moisture to penetrate into the internal structure. These weathering processes follow predictable patterns for limestone construction in subtropical environments, though the castle's unique design presents specific preservation challenges. The weathering process affects construction details that could provide insights into Leedskalnin's building methods. Tool marks on stone surfaces become less distinct over time as natural erosion smooths the limestone's texture. Joint connections between massive blocks show gradual changes as the stones settle and adjust to environmental conditions over decades. The mortar-free construction that relies entirely on weight and friction for stability requires ongoing monitoring to ensure that natural settling doesn't compromise the structural relationships between individual blocks. Electromagnetic field measurements taken periodically show variations that correlate with the castle's physical condition and environmental factors. The underground electromagnetic patterns detected by modern instruments continue operating consistently, but surface readings fluctuate based on moisture levels, temperature changes, and seasonal variations in the limestone's mineral content. Stones that interact most strongly with electromagnetic fields show readings that vary with weather conditions and the amount of moisture present in the porous limestone structure. Modern preservation efforts focus on protecting the castle's structural integrity while maintaining the site's historical authenticity. Conservation specialists apply treatments designed to slow limestone deterioration without altering the stone's fundamental properties or appearance. These preservation methods must balance protection against weathering with preservation of the original construction details that provide evidence of Leedskalnin's techniques. The challenge involves protecting the castle from environmental damage while avoiding interventions that might change the characteristics that make the site scientifically significant. The correlation between structural condition and electromagnetic properties suggests that the castle's unusual characteristics depend on maintaining specific physical relationships between the stone components. Visitors continue to report electromagnetic effects when touching certain stones, though these experiences vary with environmental conditions and the stone's moisture content. Electronic device malfunctions still occur at predictable locations throughout the castle grounds, indicating that the electromagnetic phenomena result from permanent features built into the construction rather than temporary conditions. Changes in the castle's structural condition provide opportunities to study how Leedskalnin's engineering responds to environmental stresses over time. As limestone blocks develop natural stress patterns from thermal expansion and moisture cycles, researchers can observe how these changes affect the electromagnetic properties that distinguish Coral Castle from ordinary limestone construction. The gradual settling and adjustment of massive stone blocks reveals information about the precision of the original construction and the engineering principles that maintain structural stability without conventional foundations or reinforcement. Historical photographs spanning 8 decades document the castle's evolution and help researchers understand how environmental factors affect different areas of the construction. Comparison images show that certain stone surfaces have changed texture and appearance over time, while joint lines between blocks have adjusted as the structure responds to environmental conditions. These photographic records provide baseline measurements for current preservation efforts and help identify areas where natural weathering poses the greatest threats to structural integrity. Florida's climate presents ongoing challenges for limestone preservation through cycles of intense heat, heavy rainfall, and high humidity that affect the stone's chemical composition. Hurricane seasons subject the castle to extreme weather conditions that test the structural engineering principles Leedskalnin incorporated into his design. The castle's response to these environmental stresses demonstrates the effectiveness of his construction methods while revealing areas where modern preservation techniques can provide additional protection. Tourism impacts require careful management to balance public access with preservation of delicate construction details throughout the castle grounds. Thousands of visitors each year interact with the stone structures in ways that gradually affect surface textures and joint alignments. Tour management protocols limit direct contact with the most vulnerable areas while maintaining the interactive experiences that help visitors appreciate the precision of Leedskalnin's engineering achievements. Researchers continue documenting construction details and electromagnetic properties to create comprehensive records of the castle's current condition. Advanced scanning technology captures precise measurements of stone surfaces and joint patterns that reveal construction techniques invisible to earlier investigators. Electromagnetic field mapping tracks variations in the castle's energy signatures and identifies which areas retain the strongest evidence of the engineering principles that made the construction possible. The preservation challenge extends beyond protecting individual stones to maintaining the systematic relationships between components that create the castle's unique characteristics. Each block's position and orientation contributes to the overall electromagnetic environment, making preservation a complex engineering problem that requires understanding both the individual elements and their integrated functions. The evidence suggests that Leedskalnin's achievement involved not just moving massive stones but arranging them according to principles that researchers are still working to understand completely. These preservation efforts take on greater significance when considering how Leedskalnin's methods compare to construction techniques used at ancient sites worldwide, where similar engineering challenges produced remarkably parallel solutions across different cultures and time periods. Edward Leedskalnin's achievement becomes even more remarkable when compared to documented construction techniques from ancient civilizations that faced similar engineering challenges. Orville Irwin's detailed research reveals that Leedskalnin relied on simple mechanical principles rather than mysterious technologies, using tripods, blocks and tackles, and iron gears salvaged from a Ford Model A to accomplish his construction. These basic tools, combined with exceptional understanding of leverage and mechanical advantage, allowed him to manipulate massive stone blocks using methods that ancient builders would have recognized and understood. The tripod systems that Leedskalnin employed mirror techniques documented at megalithic sites worldwide, where builders used wooden frameworks to position massive stones with mathematical precision. Archaeological evidence from Sacsayhuaman in Peru shows that Incan builders used similar tripod arrangements to move granite blocks weighing hundreds of tons across mountainous terrain. The stone-cutting techniques evident at both sites demonstrate comparable understanding of how to shape hard materials using simple tools applied with extraordinary skill and patience. Leedskalnin's use of pulleys and block and tackle systems reflects mechanical principles that ancient Egyptian builders mastered during pyramid construction. Hieroglyphic records document the use of rope and pulley systems for moving limestone blocks, though the scale of operations required massive crews working in coordination. The mathematical relationships governing mechanical advantage remain constant across time periods, meaning that Leedskalnin's achievement required the same understanding of physics that ancient builders possessed, applied with remarkable individual efficiency. The iron gears from the Ford Model A that Leedskalnin incorporated into his construction equipment demonstrate how he adapted available materials to create specialized tools for stone manipulation. Ancient builders similarly repurposed available technologies, using bronze tools, wooden rollers, and rope systems to accomplish construction projects that modern engineers struggle to replicate. The creativity required to transform automotive components into stone-moving equipment parallels the ingenuity that ancient civilizations showed in developing construction techniques using materials and tools available during their respective eras. Modern experimental archaeology projects attempting to recreate ancient construction methods consistently validate the effectiveness of simple mechanical systems when applied with sufficient knowledge and skill. Teams using wooden rollers, copper tools, and rope systems have successfully moved multi-ton stone blocks, though these experiments require large crews working for extended periods to accomplish what individual ancient builders apparently achieved more efficiently. The gap between experimental results and historical achievements suggests that ancient builders possessed mechanical knowledge and techniques that modern reconstructions have not fully captured. Leedskalnin's published statements about discovering the secrets of the pyramids take on new significance when viewed alongside evidence of sophisticated mechanical engineering at ancient sites. His claim suggests familiarity with construction principles that pyramid builders used, rather than access to supernatural technologies. The mechanical advantage systems required for pyramid construction involve the same physics principles that Leedskalnin applied at Coral Castle, though implemented on vastly different scales using materials available during respective time periods. The precision evident in both ancient megalithic construction and Leedskalnin's work demonstrates mastery of surveying and measurement techniques that exceed typical expectations for their respective eras. Ancient builders achieved mathematical accuracy in stone placement that required sophisticated understanding of geometry and engineering principles. Leedskalnin's construction shows comparable precision in stone cutting and structural alignment, suggesting access to measurement and calculation methods that most builders of his era never possessed. Stone cutting techniques documented at ancient sites reveal approaches to shaping hard materials that Leedskalnin appears to have understood and applied using available tools. Ancient builders developed methods for splitting granite and limestone using wedges, thermal expansion, and controlled fracturing that allowed them to shape massive blocks with remarkable precision. The tool marks visible on Coral Castle stones suggest similar techniques adapted for working with oolitic limestone using hand tools available during the 1930s. The mathematical relationships governing structural stability remain constant across time periods, meaning that both ancient builders and Leedskalnin had to understand the same engineering principles to achieve lasting construction. Ancient megalithic sites demonstrate sophisticated knowledge of load distribution, foundation engineering, and structural integration that prevented collapse over millennia. Coral Castle shows comparable understanding of these principles applied to create stable construction using mortarless stone assembly techniques. Leedskalnin's achievement represents a unique preservation of construction knowledge that connects modern times to ancient building traditions that mainstream archaeology has struggled to explain. His success in applying mechanical principles to accomplish seemingly impossible construction demonstrates that advanced building techniques depend on understanding natural forces rather than access to sophisticated equipment. The bridge he created between ancient wisdom and modern capabilities suggests that traditional construction knowledge remained accessible to individuals who approached engineering challenges with sufficient dedication and insight. The evidence positions his work as crucial documentation of construction techniques that ancient civilizations developed and applied on massive scales using similar mechanical principles. His preservation of these methods during the 20th century provides modern researchers with practical examples of how ancient builders might have accomplished their remarkable achievements. The consistency of engineering principles across different time periods and cultures suggests that effective construction techniques represent universal applications of physics rather than culture-specific innovations. These connections between ancient and modern construction methods raise fundamental questions about how such knowledge traveled across time and geography, creating patterns that researchers are only beginning to map and understand. The ley line network exposed. Examining specific geographic coordinates reveals details about Coral Castle's placement that have attracted various theories over the decades. The castle sits at 25 degrees 30 minutes 1 second north, 80 degrees 26 minutes 42 seconds west, positioning it along the 25th parallel north that passes through several historically significant locations worldwide. This latitude line crosses through regions in Egypt, India, China, and Mexico where ancient structures demonstrate remarkable construction achievements that continue challenging modern understanding of historical building capabilities. Some researchers have proposed connections between Coral Castle and ley lines, the theoretical network of straight pathways linking sites of historical significance that Alfred Watkins introduced in 1925. These theories suggest that Leedskalnin deliberately chose his construction site to interact with invisible energy fields that supposedly connect ancient monuments across vast distances. However, geological surveys conducted at Coral Castle have found no evidence of unusual energy lines beneath the site, and no credible scientific research supports the existence of global energy grids operating through underground electromagnetic pathways. The folkloric speculation about ley lines often focuses on the mathematical relationships between distant archaeological sites, proposing that ancient civilizations possessed advanced geographic knowledge that enabled coordinated construction projects spanning multiple continents. Proponents of these theories point to the precision of ancient site placement as evidence of sophisticated surveying capabilities that mainstream archaeology attributes to coincidence rather than deliberate planning. The positioning accuracy demonstrated at locations like Stonehenge, the Great Pyramid, and Machu Picchu does suggest remarkable understanding of geometry and engineering principles, though conventional explanations focus on individual cultural achievements rather than coordinated global networks. Leedskalnin's use of dowsing rods to locate his water well, documented in historical accounts, has been interpreted by some researchers as evidence that he attempted to detect invisible energy fields at his construction site. Dowsing represents a traditional practice for locating underground water sources that rural property owners throughout Florida commonly used during the 1920s and 1930s. While dowsing lacks scientific validation, its widespread use suggests that Leedskalnin employed conventional rural techniques alongside his more sophisticated mechanical engineering methods. The astronomical alignments evident throughout Coral Castle, including the Polaris telescope and sundial arrangements, demonstrate Leedskalnin's interest in celestial relationships and mathematical precision. These features show understanding of geometry and astronomical principles that exceed typical expectations for amateur construction projects, though they fall within the range of knowledge available to dedicated self-taught individuals during the 1930s. The alignments suggest careful planning and mathematical calculation rather than random placement of architectural elements. Magnetometer readings taken at various points throughout Coral Castle do reveal electromagnetic variations that differ from baseline measurements in surrounding areas. These readings show concentrations of electromagnetic activity near specific structures, particularly around the 9-ton gate and carved stone chairs. However, The electromagnetic signatures fall within ranges typically found at sites containing large amounts of limestone and metal components, rather than indicating supernatural energy fields or connections to global networks. The electromagnetic anomalies detected at Coral Castle appear to result from the interaction between the coral limestone's natural mineral content and the metal components that Leedskalnin incorporated into his construction. Similar electromagnetic variations occur at other limestone formations throughout Florida, though they lack the systematic arrangement and precision engineering that characterizes Leedskalnin's work. The difference lies in how the materials are shaped, positioned, and integrated into the overall structure rather than in exotic energy sources or mystical connections to distant sites. The consistency of electromagnetic effects reported by visitors over decades suggests that Coral Castle's unusual characteristics result from permanent features built into the construction rather than temporary phenomena or psychological suggestion. Electronic device malfunctions, compass deviations, and other documented effects follow geographical patterns that correlate with the underground electromagnetic variations detected by scientific instruments. These effects demonstrate measurable interaction between the castle's design and natural electromagnetic fields present in the local geology. Theories connecting Coral Castle to global energy networks often overlook the more remarkable achievement that Leedskalnin actually accomplished using conventional physics and exceptional engineering skill. His success in moving massive stone blocks using mechanical advantage systems represents a documented example of individual innovation that transcends apparent limitations imposed by available tools and resources. The precision and scale of his construction demonstrate mastery of engineering principles that most builders of his era never possessed, achieved through careful application of mechanical knowledge rather than access to mysterious energy sources. The electromagnetic properties that continue affecting visitors and electronic equipment at Coral Castle provide concrete evidence of engineering achievements that operate according to measurable physical principles. The ongoing effects suggest that Leedskalnin's construction methods incorporated elements specifically designed to interact with natural electromagnetic fields in ways that create lasting phenomena. These characteristics raise questions about the extent of his technical knowledge and whether his methods could be applied to solve other construction challenges that seem impossible using conventional approaches. The persistent electromagnetic anomalies and their correlation with specific construction details suggest that Coral Castle represents something more significant than a folk art curiosity, though the significance lies in documented engineering achievements rather than connections to mystical energy networks. The site continues attracting attention from researchers and government agencies who recognize that Leedskalnin's methods challenge conventional understanding of individual construction capabilities and may have implications that extend beyond historical curiosity. Government interest and cover-ups. Historical documentation reveals that Edward Leedskalnin's remarkable achievement attracted attention from researchers and media outlets, though the actual record differs significantly from sensational claims that have emerged over the decades. Local Florida newspapers provided brief coverage of the castle during Leedskalnin's lifetime, focusing primarily on the curiosity of one man building such an elaborate stone structure using hand tools. The Miami Herald published several articles between 1936 and 1951 describing the castle as a folk art attraction, though reporters struggled to explain how Leedskalnin accomplished his construction using the simple equipment visible at the site. Julius Levin played a crucial role in promoting Coral Castle after purchasing the property following Leedskalnin's death in 1951. Levin recognized the commercial potential of the mysterious construction and began developing the site as a tourist attraction while encouraging speculation about supernatural building methods. His promotional efforts emphasized the unexplained aspects of the construction, marketing the castle as a place where impossible engineering had somehow been achieved. Levin's business approach helped establish many of the theories about exotic construction techniques that continue attracting visitors and researchers to the site. The documented history shows that Leedskalnin worked largely in isolation, avoiding publicity and rarely discussing his construction methods with neighbors or visitors. Contemporary accounts describe him as a private individual who preferred working at night and discouraged people from observing his building activities. Local residents occasionally reported seeing him moving stones using tripods and pulleys, though few witnessed the actual lifting and positioning of the largest blocks. The secrecy surrounding his work methods contributed to speculation about his techniques, though the mystery appears to result from his preference for privacy rather than use of supernatural technologies. Press coverage during the 1940s and 1950s focused on the engineering puzzle that Coral Castle represented rather than suggesting government involvement or classified research programs. Reporters interviewed structural engineers and construction professionals who expressed amazement at what one person had accomplished using apparently simple tools. The articles emphasize the mathematical precision evident in the stone cutting and placement while acknowledging that conventional construction methods could not explain how Leedskalnin achieved such results working alone. The coverage treated the castle as an engineering mystery worthy of scientific investigation rather than a national security concern. Tourism development under Levin's ownership transformed Coral Castle from a private residence into a commercial attraction that emphasized the mysterious aspects of its construction. Levin installed tour guides who presented theories about magnetic levitation, anti-gravity devices, and other exotic explanations for Leedskalnin's achievement. The promotional materials suggested that visitors might experience supernatural phenomena while touring the castle, encouraging speculation about ongoing electromagnetic effects and unusual energy fields. This marketing approach established many of the legends that continue surrounding the site, though it often prioritized entertainment value over historical accuracy. Scientific interest in Coral Castle has remained consistent since the 1960s, with researchers from various disciplines attempting to document and explain the construction techniques that Leedskalnin employed. University engineering departments have conducted studies of the stone cutting precision and structural stability, while physics researchers have measured electromagnetic effects reported by visitors. The academic investigations have focused on conventional explanations for the construction methods, though they acknowledge gaps between what should be theoretically possible and what Leedskalnin obviously accomplished. The evolution of theories about Coral Castle reflects broader cultural interests and alternative explanations for historical achievements that challenge conventional understanding. Early speculation focused on mechanical engineering solutions that might explain how one person could move massive stones using available tools and equipment. Later theories incorporated electromagnetic phenomena, energy manipulation, and connections to ancient construction techniques as researchers struggled to bridge the gap between theoretical possibilities and documented results. The progression of explanations demonstrates how scientific understanding has evolved while the fundamental mystery of Leedskalnin's methods remains unsolved. Documentation from the Florida State Archives provides administrative records showing that Coral Castle operated as a private tourist attraction without unusual government oversight or regulatory restrictions. Building permits, tax records, and business licenses follow standard patterns for commercial properties in Homestead during the mid-20th century. The paperwork shows no evidence of special monitoring, classified research programs, or security restrictions beyond normal requirements for tourist attractions. The administrative trail suggests that officials treated Coral Castle as an unusual but conventional business operation rather than a site requiring special attention or investigation. The gap between documented history and popular theories about Coral Castle illustrates how remarkable achievements can generate speculation that exceeds available evidence. Leedskalnin's construction methods remain genuinely mysterious despite decades of investigation by engineers, physicists, and other researchers. The absence of conventional explanations for his techniques has created space for theories that range from plausible mechanical solutions to exotic technologies involving electromagnetic manipulation or anti-gravity effects. The persistence of these theories reflects both the genuine puzzle that Coral Castle represents and the human tendency to seek extraordinary explanations for extraordinary achievements. Modern research efforts continue building on the foundation of documented history while applying advanced technologies that previous investigators could not access. The combination of historical records, physical evidence, and sophisticated analytical tools may finally provide answers to questions that have persisted for nearly a century since Leedskalnin completed his remarkable construction project. The future of Coral Castle research. Current preservation efforts at Coral Castle rely on standard historical research methods and established stone conservation practices to protect the site for future generations. The Florida Department of State's Division of Historical Resources oversees conservation work that follows proven techniques for maintaining limestone structures in subtropical climates. Specialists apply protective treatments designed to slow natural weathering while preserving the original construction details that provide evidence of Leedskalnin's techniques. These preservation methods balance protection against environmental damage with maintaining the site's historical authenticity and scientific value. Modern documentation projects focus on creating comprehensive records of the castle's current condition using established archaeological and engineering survey methods. Digital photography captures detailed images of stone surfaces and joint patterns that reveal construction techniques invisible to earlier investigators. Precise measurement systems record the exact dimensions and positioning of each major structure, creating baseline data for monitoring changes over time. These documentation efforts provide researchers with detailed records of Leedskalnin's achievement while establishing protocols for detecting any structural changes that might affect the castle's stability or historical integrity. Research teams continue applying conventional scientific methods to study the electromagnetic phenomena that visitors have reported for decades. Magnetometer surveys map the electromagnetic field variations throughout the castle grounds using standard geological survey equipment. The readings provide technical documentation of the energy signatures that correlate with visitor experiences and electronic device malfunctions. These measurements follow established protocols for electromagnetic field detection, creating scientific records that future researchers can use to understand the relationship between the castle's construction and its unusual electromagnetic properties. The engineering analysis of Leedskalnin's construction methods focuses on understanding how he achieved such remarkable results using mechanical systems available during the 1930s. Structural engineers examine the precision of stone cutting and placement to determine what tools and techniques could have produced such accuracy. Mechanical engineering specialists study the pulley and lever systems documented in historical accounts to calculate the theoretical force requirements for moving massive stone blocks. These conventional engineering approaches provide frameworks for understanding Leedskalnin's achievement within the boundaries of established physics and mechanical principles. Educational programs at Coral Castle encourage visitors to examine the physical evidence and form their own conclusions about how the construction was accomplished. Tour guides present the documented facts about Leedskalnin's life and work while acknowledging the gaps in understanding that continue puzzling researchers. The educational approach emphasizes critical thinking and scientific observation rather than promoting specific theories about exotic construction techniques. Visitors learn about the mechanical engineering principles that could explain the construction while experiencing the electromagnetic phenomena that make the site scientifically significant. Academic institutions continue studying Coral Castle as an example of exceptional individual achievement that challenges conventional understanding of construction capabilities. University engineering departments use the site as a case study for teaching students about mechanical advantage, structural engineering, and problem-solving under resource constraints. Physics researchers investigate the electromagnetic effects as examples of how natural materials can interact with electromagnetic fields in measurable ways. The academic interest ensures that scientific investigation continues using rigorous methods that build on established research rather than pursuing sensational theories. The preservation challenge extends beyond protecting the physical structures to maintaining access for researchers and visitors who want to study Leedskalnin's achievement firsthand. Tourism management protocols balance public access with conservation requirements, allowing people to experience the castle while protecting delicate construction details from damage. The site's educational mission depends on preserving both the physical evidence and the opportunity for direct observation that enables visitors to appreciate the scale and precision of what one person accomplished working alone. Future research directions will likely focus on applying improved analytical techniques to questions that previous investigators couldn't address using available technology. Better electromagnetic field detection equipment may reveal additional details about the energy signatures that distinguish Coral Castle from ordinary limestone construction. Advanced materials analysis could provide insights into how Leedskalnin selected and prepared his building materials to achieve specific structural and electromagnetic properties. These technological improvements will build on the foundation of conventional research methods rather than pursuing exotic theories that lack scientific support. The ongoing investigation of Coral Castle serves broader scientific interests in understanding human capabilities and the potential for individual innovation to transcend apparent limitations. Leedskalnin's achievement demonstrates what exceptional skill and determination can accomplish when applied to problems that conventional wisdom considers impossible to solve. The site provides concrete evidence that challenges assumptions about technological requirements for major construction projects and suggests that human ingenuity can find solutions that exceed the capabilities of available equipment and resources. The most valuable approach for anyone interested in understanding Coral Castle involves visiting the site and examining the physical evidence directly. The scale and precision of Leedskalnin's construction become apparent only through personal observation of the massive stone blocks and their mathematical arrangement. The electromagnetic effects that continue affecting electronic equipment provide immediate evidence that the castle operates according to principles that researchers are still working to understand completely. Direct experience with the site offers insights that no amount of theoretical discussion can provide, making personal investigation essential for anyone seeking to comprehend what Edward Leedskalnin actually accomplished in the coral rock quarries of South Florida. The evidence gathered through decades of investigation reveals that Edward Leedskalnin accomplished something extraordinary using conventional materials and mechanical principles applied with exceptional skill. The electromagnetic phenomena documented at Coral Castle result from sophisticated engineering that maximized the natural properties of oolitic limestone through precise construction techniques. His achievement demonstrates what individual determination and mechanical ingenuity can accomplish when applied to problems that conventional wisdom considers impossible to solve. Though many myths persist about supernatural technologies and mysterious energy sources, Coral Castle stands as a tribute to one man's vision and ingenuity. Come see what hard work and creativity can accomplish.